Hello and welcome to part 2 of creating an underwater survival day. In this episode, we will be creating a day-night cycle for our world as well as creating terrain. Now to start off the episode, in the previous episode there was a small error in the player controller script. So if you went to move and you went to the code that sets the velocity of the rigid body, you'll notice that over here it says move Y when it's actually supposed to say move Z because movement on land is controlled by X and Z. So yeah, we've got to fix this error before we can move on. Okay, now for the first part of today's episode, we are going to be create the day-night cycle for our game. So I'm going to go to scripts and I'm going to create a new folder and I'm going to call it time. In this folder, all scripts that manage time will be put in here. So in order to create a day-night cycle, we need to rotate the directional light of the scene. So if you look at the directional light, if you rotate it, it actually looks like the sun is rising and setting. So we will need to rotate it in code in order to create the day-night cycle. In order to rotate it accurately, I'm going to set up a time system that will keep track of how many in-game hours, minutes, and days have passed. And with that, we'll be able to move the sun. This time system will also be able to allow us to set events. So if, for example, if we want a certain action to happen after 6 in-game days, then we can use this time system to trigger it. So this time system is a bit complicated. So I'm going to start off by creating a new class called game timestamp. So if we open it, we can see that it's a brand new class. So game timestamp will be a class that will store the number of minutes, days, and hours that have passed. So it's not going to be a mono behavior class, so we can delete that. We also need to make it serializable so that we can see it in the inspector. Since this is not a mono behavior class, there's no need for start or update. Yeah, so in this class, I'm just going to create variables to store the day, hour, and minute. So first of all, we need to create a class constructor. This will be used to help set up the class every time we need to create a game timestamp. Afterwards, we need a function that will help us create a game timestamp from an existing one. So this function will just be used so that we can create a new timestamp from an older timestamp, and it just sets the timestamp day, hour, and minute to the other timestamp day, hour, and minute. The next thing that we need to do is to create a function that will increase the time. So it would be a function that every time it's called, it would increase the minute by 1, and that it also makes sure that the minute doesn't exceed 60. And it's also responsible for converting minutes to hours and hours to day. So for the Subnautica game, I'm going to count 1 second of real time as 1 minute of game time. And so 1 minute of real time to be 1 hour of game time. Do note that in Subnautica, the length of one day is actually 20 minutes, which would be 20 in-game hours. With that, we have our update clock function. After this, we will need to create 2 more functions, one that converts hours to minutes, and one that gives back the current timestamp in minutes. Next, we'll create the function timestamp in minutes. This function takes in a game timestamp and returns the total minutes of that game timestamp. So these functions will be used to help with other functions in the time manager, such as rotating the directional light. With that, our game timestamp code is complete.
The next thing we need to do is to create a class to manage the game timestamps.
So I'm going to go back to Unity, going to go back to our scripts folder, and I'm going to create a new script, and we're going to call it TimeManager. So just open it up. Game TimeManager will be a mono behavior script, and it will also be a singleton class. So to make sure that it's a singleton class, I'm going to enter some code. So I'm going to create a static instance of the time manager. It's going to have a public get and a private set so that other scripts can access it but can't change it. And this is where we'll store our time manager to make sure that we don't duplicate it. The next thing we need to do is to make sure there's only one instance of the class at a time. So I'm going to do this in awake. So in this case, if there's more than one instance, we destroy the copy. And if there isn't, we will just set the instance to be this copy. Now the next thing we want to do is to have this class handle the game timestamp and also update the timestamp. I'm going to create a new header. I'm going to call it internal clock. I'm going to add a game timestamp called timestamp and a timescale which is set to 1. The timescale will be used to just multiply the speed of the game if we want a fast forward mode like in The Sims. Now if we go down to start, we will want to initialize the timestamp. Now in order to update the game timestamp, I'm going to use a coroutine with a while loop. Since 1 minute in game is equal to 1 second real time, we'll update the game timestamp every second. I'm going to start by creating the coroutine. I'm going to call it time update. And while it's true, I'm going to do timestamp.updateClock. After that, I'll yield return new wait for second 1 divided by timescale. Now that we have our time update coroutine, we just need to call it in start. With this, the time manager should now be able to initialize a game timestamp and then continually update it every second. So I'm just going to return to the Unity. I'm going to create an empty object and I'm going to name it Game Manager. The Game Manager will be used to store the UI as well as different management classes. So I'm just going to drag player canvas to become a child of Game Manager. Oh, I'm also going to reset the position of Game Manager. After that, I'm going to add Time Manager to become a component of Game Manager. And so you can see we can now change the time scale as well as set the day, hour, and minute. Okay, the next part of our video, we're going to look into the sun rotation. Obviously, we will want the sun to rotate every second and reflect the current timestamp. So in Subnautica, if you recall, the day is actually 15 minutes, which equates to 15 in-game hours, and the night is 5 minutes, which equates to 5 in-game hours. So if I pull up my notepad, so for the daytime, we want the sun to be going from 90 degrees to negative 90 degrees. So we need to rotate 180 degrees in 15 in-game hours. And then at night, we need to rotate another 180 degrees from negative 90 to 90 in 5 in-game hours. So if we calculate this, during the day, we would rotate 12 degrees an hour, which would then calculate to rotating 0.2 degrees a minute, which equates to 0.2 degrees every second. However, at night, we only want to rotate over 5 hours. So if we take 180 divided by 5, we rotate 36 degrees every hour. And that equates to 0.6 degrees a minute, which is 1 second in real time. So now we have these numbers, we can return to the code. If we open up TimeManager again, we need to set some variables in order to complete the day-night cycle. So I'm going to create another header called day and night cycle. In these variables, we will have the transform of the directional light, which we'll call the sun. After this, I need to create a new function that will update the sun movement. I'm going to call it update sun movement. So this will be called along timestamp.update clock. So in this function, we'll be getting the time in minutes. So we will take the game stamp time and get the time in minutes. And then we will move the sun based on whether it's daytime or nighttime. So during daytime, the sun will move 0.2 degrees in a minute. And during the nighttime, the sun moves 0.6 degrees in a minute. Now, in order to move the sun based on the correct angle, I'm going to use an if statement. So first, I'm going to create a temporary float called sun angle, which will keep track of what the angle will end up multiplying to be. Then we're going to check if the time has been less than 15 in-game hours. So in minutes, that would be 15 times 60. So if it's less than 15 in-game hours, that means that it's daytime. Thus, we would use the daytime angle multiplied by the time in minutes. Then we want to check if the time in minutes is actually more than 15 hours. So if it was nighttime, we cannot take the time in minutes multiplied by 0.6 because we're not counting the 180 degrees that we rotated in 0.2 degree angles. So here's what we do instead. So here we need to take 0.6 multiplied by how many minutes it's been since it's been nighttime. And since we know that in 15 hours we move 180 degrees, we just add that to our result. And that will give us the correct sun angle. Now all that's left to do is to apply the angle to the directional light. Now that we've created our update sun movement function, we can now add it to the time update. So I'm going to create another function and I'm going to call it tick. And here I'll just put in timestamp.updateClock as well as update sun movement. Then in time update, I'm just going to call tick. This is to keep our code neat so that time update isn't polluted with a bunch of lines of code in case we need to add more stuff to tick later on. Now we just save the code and we return to Unity. So we go to our game manager. We can add the directional light transform to the TimeManager script. With this, we should be able to see the movement of day and night. I'm just going to speed it up to 20. And if I click play, the sky should start rotating. So if I look at the directional light, yeah, you can see that the X rotation is indeed changing. And yeah, so it is actually getting dark now. And then if we wait for a while, yeah, the sun rises. So let's just set this back to 1. However, there's a slight problem. If we click play and we set this to 19, it's nighttime and it's about to be daytime. And if I set the time to about 20 seconds and we look at the sunrise, you can see that the movement isn't very smooth at all because it's rotating 0.6 degrees every second, but it's not being interpolated. So it's actually quite, it's not smooth, which is not good. So I'll teach you a way to fix this in the code. So here's what we're going to do. So here we have an angle that we want the sun to rotate towards every second. So what we'll do is to actually use quaternion.slurp to rotate the sun, which will make it make the rotation smoother. So what I'm gonna do is just under day-night cycle, I'm gonna create a vector 3, and I'm gonna call it sun angle. And then if I scroll back down to the code, instead of directly setting the Euler angle of the sun, I'm just going to comment out this line. Instead, I'm going to set sun angle to be this vector. Afterwards, I'm going to go to update actually. And then in update, I'm going to use quaternion slurp to rotate the sun. And with that, the rotation should actually become smooth. So if I enter the play scene again, and actually if I drag this, you can actually see, if I look up, the sun actually, even if I change this value to perhaps 10, the sun actually moves in real time to respond to that. So it just makes it look a lot cleaner when you're, if you're fast forwarding on time. So yeah, even if you change the value here, you can see the sun move in accordance with it. Yeah, this should smooth out our sun movement. So if I change it to 19, so you can see the movement is much smoother now in real time. Sunrise. Yahoo! That's all for the sun rotation. So one last thing we need for our time manager, we need some debug functions. So in future, we're going to be using the time manager to control a lot of different aspects of the game. So I'm just going to add some debug functions right now. So we're going to add a function to skip time and a function to get the current timestamp. So in this function, we're going to call it skip time, and it'll make sure that even when you skip time, it updates all of the things in tick properly. So skip time will take in a game timestamp that you want to skip to. Then it will calculate the difference in minutes from the time right now to the time then. Then it will repeatedly call tick until the desired time is reached. For our other debug function, this is just a function that returns a clone of the game timestamp. So that's all the code for Time Manager. For the last part of our time system, we're going to be creating a Unity interface, and we're going to call it Time Tracker. So a Unity interface is like a collection of method signatures and properties. So a class can then implement an interface and change the code, and then every time that an interface is implemented into a class, it is treated as an instance of that interface. So it's easy to group together all of those interfaces and treat them the same way, even if they have completely different codes within them. Why we're making an interface is so for our time management system, we want to be able to inform a class when a certain time is met, and so that class can do an action. For example, if we want to trigger an event on the sixth day of the gameplay, we can use the interface to help keep track of what time it is before the event can happen, instead of referring to the time manager script all the time. So I'm going to create the interface now. In the same folder, I'm going to create a new script, and I'm going to call it I Time Tracker. The I stands for interface. So we're gonna remove the model behavior and we're actually gonna change class to interface. And I can remove the start values. So in this interface, we want to add a function called clock update. And then when we implement this interface, clock update can be used any way you want. So now if I go over to the TimeManager script, if I go to the variables, I can add the time trackers. Here we're just going to create a list of all the time tracker interfaces. Now if we go to tick, we can actually implement we can call clock update with the current timestamp. With this, every time the clock updates, it will send out a message to each time tracker. So yeah, we'll be implementing this in a later episode, but like feel free to use this however you like if you want to add your own twist to the game. For the listeners, we're also going to be adding two functions to add and remove listeners. They're just to handle the listeners list. With that, we've set up everything that we need for our time manager scripts. Yeah, so we have game timestamps, the time manager, which manages the time, and the time tracker interfaces. Now for the second part of the episode. In this part, we'll be learning how to build terrain for your game, because right now we just have this demo terrain from the Aquaslide package, but we want to create our own terrain. So how to do this? First of all, you need Unity has some built-in terrain tools, and they also have a package with terrain. So if I go to Unity registry, and if I go to package manager, and I go to settings, and I go to advanced settings, I can actually enable preview packages. Because the advanced terrain is preview package. So if I just type in terrain tools. So this terrain tools gives you a few extra types of brushes and cool stuff you can do with the terrain. So you can just install it to your project. If you look over here, there's a button to download asset samples from the asset store because the asset store has some samples of terrain that you can pick from and stuff like that. So like if you go to the asset store and you find a terrain that you want to use, like go ahead and use that, or you can just build your own terrain. Now that that's done, I'm going to open a window and I'm going to go to terrain, and I'm just going to open up the terrain toolbox and put it next to my inspector. These are great, so you can you can create new terrain from here. There's some utilities as well as visualization modes to help you make your terrain easier. There's some settings that you can change for your terrains, and you can create presets for them too. Yeah. So what I'm going to do is first I'm going to create a new terrain that's 500 by 500. And I'm going to create it with a height of 1000. So I'm just going to click create at the bottom here, and it'll create a terrain group, and inside that there'll be a terrain. I'm just going to move this out of the way. So as you can see, the terrain is quite large. So I'm just going to move this further back. Now if we go to inspector, you can see that terrain group has a terrain group script as well as a group ID. So this ID will be used by all terrains within the group so that they can be identifiable if you have a bunch of different terrain maps. So I'm going to start over with this one. So here, if I click on the paintbrush in the terrain aspect, you can see there's a bunch of options that come up. Terrain is quite a powerful tool. If you click here, it allows you to create neighbor terrains in the surrounding squares. Here there's the brush tool where you can do lots of things. You can stamp terrain, smoothen the height, set the height, transform, paint texture, paint holes. You can raise or lower terrain. You can stamp terrain. You can do erosion effects with 3 different types, as well as regular effects. And you can also sculpt. So I'm just going to click raise or lower terrain. I'll go through the different brushes with you. So you see left click to raise terrain, control and left click to lower terrain. So for now I'm actually going to go to set height, make the brush quite large, and I'm going to select this. So I'm going to raise the height by a little bit, and then I'm going to hold control and I'm going to click again, and I'm going to sample the height. So I'm taking this height as the height I want to set the terrain at. And now that I've sampled this height, if I hold left click, I can actually increase the height to be exactly that much. So that's the set height tool. If I were to go to raise or lower terrain, now I can increase the terrain height. I'm going to create a softer brush and I'm going to reduce the brush strength, and then I'm going to increase the brush size. So now I can create hills. I can create them in different shapes too, even star shapes. So yeah, this tool can do quite a lot of different things. You can hold control while with this brush to decrease the height again. If I go to terrain toolbox and I go to terrain visualization, I'll actually use the altitude heat map to help me see it a bit better. Yeah, now I go back to the inspector. So yeah, you can play around with the tools a lot. They can do quite a lot of different things. Next, we'll be looking at sculpt. If we go to sculpt and I click terrace and I zoom in on one of these mountains, I can actually create a terrace effect on these mountains, which can be quite good depending on the style of the game you want to create. If I do things like bridge, I can click on tool. If I do bridge, I can control click to set a starting point, and then I can click and it will actually create a bridge between those 2 points, a smooth slope between those 2 points. I can also flatten some of the slopes. There is also the hydraulic erosion tool. When you use it, you can actually wear away the terrain as if it's being worn away by water. So it's a very useful tool for making the terrain look like it's worn down. And if I go over to creating neighbor tiles, you can set the mode to clamp or mirror. I'm going to pick mirror because as you can see, it actually height matches your terrain. So it's really easy to expand your terrain. Don't forget to make sure that the terrain are all children of the terrain group and all have the correct IDs.
So the next thing we want to do is learn how to paint texture onto the terrain.
So you want to go to the paint texture tool, and then you would want so what you'll do is go to the paint texture tool, and you have your brush settings still, but now you have a material layer as well as a palette layer. I'm just going to take the terrain and change it back to none, so now it's gray again. And now in the layer palette, this is the color palette we're going to be using to paint the terrain. So I'm just going to add a new layer. I'm just going to use the textures from the Aqua Slide demo to paint, but you can use whatever textures you like. If you find ones that you prefer better, you can use them too. So yeah, all the terrains you can set a base color. Now if you pick a different texture, you can just start painting the terrain. Just drag across where you want the texture to appear and it'll appear there. Simple as that. So you can increase the brush size, I can make this part green, and then if I select brown, I can go and create some brown sand over here. Then if I were to click on this, I can change this part to have that texture instead. You can even like overlay them a bit. So here I'm just gonna put it on the edges of this biome. Okay, now I'm going to make the terrain for real. Now that I've shown you how the general tools work, feel free to play around. They also has function to paint trees and details as well. So yeah, you can get to that later. Now I'm just going to start with a blank slate and create the new terrain.
I'm actually going to reduce the size of this terrain to be a bit smaller. As you can see, when you change the size, it actually automatically scales everything according to the size you change it to. This is to make sure it doesn't seem so tiled. I'm just gonna add a little bit more texture as well. The only thing left to do is to move the player over to the terrain and then also add the water plane. Just gonna duplicate this. I'm gonna make it a child with terrain group also. And I'm going to drag it to a similar height. Now if I just move the player over, now he's standing directly on the terrain, so if I press play we can see how the terrain works. And then one more thing, we need to put in the water collider. Now I can playtest the game again. So right now I can swim since I'm underwater, and if I look around, the terrain seems to be about the right size for me. So yeah, you can swim all the way to the bottom layer. Okay, that's it for terrain. Thank you for watching this episode and see you next time. Don't forget to like and subscribe and follow the channel. Goodbye.